Welcome back to NASA's Earth Expeditions.
A quick glance at the many Earth science field projects NASA is conducting around the world this year.
We've been scaling heights and diving deep for new important insights about our planet, from underground in Alaska to in the air above the eastern United States, and we're even circling the remote parts of the global atmosphere.
And these field campaigns are preparing tomorrow's Earth scientists today. These experiments give students and early career scientists the opportunity to engage with NASA Earth science, from building, testing, and flying instruments to collecting and analyzing data, helping foster a new generation of Earth system scientists who can turn NASA's global view from space into new insights.
And the circle of Earth science life continues.
Let's take a quick peek at NASA's ABoVE mission.
ABoVE is the Arctic Boreal Vulnerability Experiment, which is getting down and dirty into the study of climate change in the Arctic and boreal, or far northern regions of our planet. NASA scientists are gaining a better understanding of the vulnerability and resilience of the delicate and large ecosystems there.
Well, we're trying to quantify how climate change is impacting fires. So the idea is that as the planet gets warmer, we're seeing hotter and drier summers, and that in turn is resulting in more severe fires. And what I mean by severe fires is a greater consumption of the soil. So historically, or in the past, the soil would burn just a minimal amount, and now maybe we're seeing a deeper burning. In these ecosystems, a lot of carbon is stored in that soil layer. So if we're burning really old carbon that had accumulated over numerous fire cycles, so hundreds, maybe even thousands of years old, that's going to be released into the atmosphere and then cycle back into more climate warming.
Well, the heat's been on here in the continental U.S. this summer, and despite the hot days on the tarmac, our team from the Langley Research Center has been all over the country investigating atmospheric carbon with ACT America.
ACT America is using 2 NASA aircraft to measure atmospheric carbon dioxide and methane over the eastern half of the U.S. during all 4 seasons and under a whole range of weather conditions. The mission will advance our ability to predict and manage future climate change by helping us better understand where carbon in the atmosphere comes from and where it goes. One of the things I think to understand is that atmospheric science can be really tough to do because the atmosphere is always moving. And take like a typical cold front moving into a warm area here, right? You've got clouds forming, you've got air masses going up and down, and we're trying to trace something like CO2 or methane coming from a natural source or coming from a well, and we want to know where it goes. And so you need to take your airplane and see what it's like to go right through the front, through a cloud, come over here to the warm sector and things like that.
Yeah, and it's really interesting too, because a lot of this carbon, it actually is moved around a lot through our weather systems, through our storms and things like that. So ACT America is really cool because it's actually going to be flying through storms during the summer months and the winter months, which is important because for satellites are great, you know, but they can't quite see through clouds and they can't quite do it through the storms like our field campaigns and our planes will be able to.
Yeah, and it makes, planes are so complementary to what we do with satellites, because they can go in and see really fine scaled stuff, but we can build it all together into our models. Take the satellite data, take process level knowledge that we get here, and get a better understanding of how the Earth works.
This will be helping us a lot in learning where the sources and the sinks are for the carbon cycle.
We're learning a lot from this airborne mission.
And it's great to see all the different applications and missions that NASA's C-130 aircraft is involved in.
Well, the DC-8 has also been getting a lot of airtime, this time on NASA's ATOM mission.
The ATOM mission is the atmospheric tomography experiment or mission. And this is a mission to go out and look at gases all over the planet, down the Pacific and then back up the Atlantic. A suite of more than 200 trace gases in our atmosphere. We are measuring over 200 gases, and these include the primary greenhouse gases like carbon dioxide, methane, nitrous oxide, all the famous ozone-depleting substances like chlorofluorocarbons, and then other more exotic species, volatile organics, and we're measuring aerosols. So it's just a huge suite of gases that we're measuring. Methane and CO2 and nitrous oxide, these are greenhouse gases. So the more you add into the atmosphere, the warmer the surface is going to become with time. And so you want to understand how these gases are controlled in our atmosphere. We know we're releasing them. The question is, how are they removed? And it's really important to understand the minor gases that remove, in particular, methane in our atmosphere. So the ATOM mission has a number of places it's going to. The first thing it's going to do is it's going to leave California, fly up towards the North Pole, and then land down in Alaska. Then we're going to go from Alaska to Hawaii, Hawaii to American Samoa in the southern hemisphere, then American Samoa down to New Zealand, then New Zealand over the southern tip of South America and Chile, then up the Atlantic to Ascension Island, then from Ascension Island to the Azores all the way up to Greenland, and then down across the Canadian Arctic and Canada, across the US, back to California. The whole ATOM trip, knock on wood, will take about 26 days to execute. You know, the way the Earth works is a fascinating puzzle. There are a huge number of gases out there in our atmosphere. We just normally think of nitrogen and oxygen. Those are the two primary gases, N2 and O2. But there are hundreds and hundreds of other minor species. And those minor species are actually really important to understand how the Earth works. And so I'm really interested in atmospheric science to understand how air moves, how this air with these different gases moving around, how it affects our planet.
So that's it, another amazing A+ analysis of NASA airborne science.
And the ATOM mission just wrapped up their 26-day mission around the world.
From Alaska to Hawaii to New Zealand, around South America, and all the way back up to Greenland, and finally back to Armstrong Flight Research Center, the hard way.
That really is a global view. Well, that is the best way to get a global picture of how air pollution and greenhouse gases cycle around the Earth.
ATOM, Act America, and above, you can learn more about all these by checking out nasa.gov for all the latest Earth expeditions information.
And we're on social media sharing our pictures, videos, and science via #EarthExpedition.